What's up, guys? This is LeetCode 198 House Robber. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money of each house, determine the maximum amount of money you can rob tonight without alerting the police. So example 1, this is the amount of money that is in the house, and we need to calculate how we need to calculate the most amount of money we can rob tonight without alerting the police. So we need to take care because we cannot rob these two here because they are adjacent houses, but we can rob these two here, we can rob these two here, these two here. And let me see this one here. Yeah, the same example, but in this case, I think so 7, 10, or 9 plus 1, 10 plus 2, 2. Okay, plus 2, 12. Yes. I know this problem. The most effective solution to solve this problem is using dynamic programming, and it's not an easy subject to understand, in my opinion. And I think the only way to understand dynamic programming is to first you need to know what is dynamic programming, and you can search on the internet, you can Google it, what dynamic programming is. And after that, you can understand some approaches you can use to apply dynamic programming. You can use matrix, you can use arrays, and you can use hash maps and other things. I think that the base knowledge of dynamic programming is that you can save previous computation to use in the future. I think that's the base of dynamic programming, but it's not easy to match this solution using dynamic programming with an exercise. And I think to get this knowledge, you have, as I said before, you need to understand first what is dynamic programming. And after that, you need to practice. You can come to LeetCode and filter the questions by the dynamic programming tag and start to practice. And yes, you will probably, yes, I think you will not get it in the first time. You need to practice a lot. And after you practice a lot, I think, will start to understand what dynamic programming is. And when you see an exercise, you will start to match the solution using dynamic programming with the exercise itself. So we will solve this exercise using dynamic programming with an array to save previous computation. And after that, we will solve also using just two variables because that's the variables we actually need. So I will explain the exercise when we start. I will explain the solution when we start to write some code, because I think will be more clear to see the code instead of explaining here. Okay, so let's try to write some code. So as I said before, we'll try to explain the idea, the base idea for this solution. Let's try to use this example here. And I think that we can start by thinking that we have to know to know what is the maximum amount of money we can get here. The only way we can do that is by trying every possible solution here. So we have to try this combination, we have to try this combination, we have to try this combination. So this is the only way we can find the solution, that what is the most amount of money we can get here. And we can do that, I think, in a lot of ways. Maybe there is a solution that we can use multiple for loops to try different combinations. And we can also use, as I said when I was reading the description, that we can use dynamic programming. So the thing here is to try every possible combination. We have to try what the exercise is asking us. We have to try two houses that are not adjacent houses to get the most profit into these houses, to get the most amount of money. We can do that by declaring another integer array. This integer array will have a length greater than this one. We can declare this array like, I think, like this. So math.length plus 1. So we have one index more compared to the input array. And why we needed that? Because we need a helper value here, which will be the first value. Why we need this? Because if we want to compare the first value with the previous rows, the previous house that we are allowed to combine the amount of money, here in the nums array, we do not have any, we don't have any number here previous to 1. So this 0 here is, we are simulating this number, because, and why is 0? Is 0 because we will not interfere into the result, because if we are doing a calculation if you are doing a sum with two numbers, the result will be the number that is not 0 in this case. And here we will start to do our checks. So we will start to check if the current number in this DP array is greater than the current number in the nums array plus the previous number that we are allowed to make this calculation, a number that is not adjacent with the other one. So this is why we are using this DP array, and this is why we are starting this array with the value 0. Okay, so let's start by checking if the input is valid. So if the input is valid, if the input is not valid, we can just return 0. After that, we can set the first index of the DP array to 0, and we can also set the second index to be the first number of the nums array. After that, we can start our for loop, and the for loop will start at the index 1, because we will start to check if the current number in the DP array is greater than the calculation that I said before. So while nums.length, while I is less than nums.length and I++. So yes, I don't think we even need the brackets here because we need only one line of code here because we will set to the current index of DP. It's actually not the current. We will set the next index of DP because as you are seeing here, we already set the current index of DP, and we will set the next one because we will compare if the current index is the most amount of money that we will get here in these two houses that are adjacent houses. So the calculation here, we can use math.max to get the maximum value between two integers. And I think the first one will be the current value in GP, which is in this case the current value in the first index in the nums array. And we will compare it with the nums of I plus the GP array of I minus 1. So here we are doing exactly the thing that I showed before when I was explaining the rationale into this solution. Okay. So when we get out of this for loop, the last index of the DP array will contain the result for this exercise. So we just need to return the DP of nums.length. And if we do not have any typo, I think this is the solution. Yes, and for this example, yes, let's try to hit submit. Yes, that's it. So as I said before, we can first thing, the type complexity here is big O of n, where n is the length of nums, and the memory complexity is also big O of n because we are allocating the same amount of money that the input. So if the input gets bigger, the allocation will also get bigger. But we can change this solution because if you see here, we are just using the one but last and the last element of this array, and we can change this to use just two variables. And to do that, we can declare here a variable called one to the last, and also a variable last. Here we can change. Now we will use brackets because we need to try some. We need to do some if statement here, because we will need here the. Let me see. So we will need an auxiliary variable because we will probably change the values between one to the last and the last variable. So an auxiliary variable to get the last value. So we can check if the last is less than this calculation here. So let's get this here. And if last is less than nums plus dp of I, we can swap the values. So we can get here, actually we can put this inside the if statement. And let me see, we can put into the last variable the result of nums of I plus dp of I minus 1. And yes, we can put into the one to the last variable, and here that's it. Otherwise we can just set the one to the last variable, the last. This else here is in the case that the last variable, the amount of money that is in the last variable is greater than this calculation here. So which means that we just need to put the current value of the last variable into, if we were using the array solution, into the next index. So when we get all of this for loop, we can just return the last variable. So we do not have the array anymore. So here is the one to the last variable, and also here. Let's try to run again. Nope. So if last is less than nums of I plus 1 to the last, here we are saving last. Last is equals to nums of I plus 1 to the last. 1 to the last is equals to last. I'm not sure where is the error. Let's try to see again. So we are putting the right values here. We are doing the check if last is less than the nums of I plus the 1 to the last. And if it is, we have to set the result of this calculation to the last variable. And this is not last, this is auxiliary. Yes, because we are doing a swap of the values here. Okay, let's try the first example. Okay, let's try to hit submit. Nice. So time complexity here is still big O of n, where n is the length of nums, the array of nums. And memory complexity, different from the previous solution, here is constant, because it doesn't matter how bigger nums get, we will always be allocating just these two variables here, also three variables, because we have these two controlling the index. But I think it's a better solution if you compare with the previous one. That's it, guys. Thanks for watching.